we present Hunt, a real-time framework for high-speed UAV navigation and tracking in unstructured and GPS-denied environments. Search and rescue often unfolds in dynamic, cluttered terrain where wind, smoke, and fire disrupt flight dynamics, sensors degrade, and GPS or communication are denied. Yet UAVs must still fly fast, avoid obstacles, and seamlessly switch from search to tracking. Hunt addresses these challenges by relying on instantaneous relative inputs rather than global maps or localization. In loitering mode, the UAV generates references only from onboard velocity, altitude, and attitude, while biasing its heading toward low-confidence detections. Once confidence is high enough, the system re-anchors its frame to the target, transitioning into tracking mode and maintaining a safe distance. In the first experiment, we show reactive collision avoidance in a dense forest. The UAV flies under canopy using completed depth images to identify imminent collisions. These are encoded as control barrier functions that constrain the controller in real time. In the bottom right panel, red points overlay the completed depth map, showing exactly which obstacles are being treated as active safety constraints while the vehicle weaves through clutter. In the second test, we demonstrate robustness across diverse environments and altitudes. The UAV flies above urban blocks and transitions from forest canopy into structured layouts. Because navigation objectives are always defined in the instantaneous frame, it maintains steady forward flight despite sudden changes in texture, lighting, and geometry. In the third experiment, we highlight high-speed tracking. Once a target is detected, the UAV re-anchors its frame to it at every cycle, so objectives like distance and heading are always defined relative to the target. This allows pursuit at speeds above 80 kilometers per hour with pitch angles over 50 degrees. The system also remains robust to temporary loss of detection. If the target is briefly occluded or blurred, tracking resumes immediately when it reappears. At the same time, the controller enforces a safety distance not only during steady flight, but also during sharp changes in target motion. When the target accelerates, the UAV ramps its velocity while keeping separation, and when the target brakes abruptly, the UAV slows down in sync, maintaining safe clearance throughout. Finally, we present complete search and rescue missions. In the urban search case, the UAV loiters until detecting a wrecked car and then locks onto it. In the dynamic pursuit, it acquires a mannequin on a speeding ATV and adapts its reference frame continuously to keep tracking. Even under abrupt speed changes, the UAV adjusts its own acceleration and deceleration while preserving safety distance. In conclusion, Hunt unifies search, acquisition, and tracking within a single instantaneous relative formulation, demonstrating robust autonomy without GPS or prior maps. Thank you for watching.